All right, continuing on fraction multiplication information, we're going to try to look at the question of why do we multiply numerators and denominators when multiplying fractions. So for example, if I had 2/3 times 4/5, I say I multiply the top and I get 2 over 4, and I multiply the bottom and I get 3 times 5. Sorry, 2 times 4 is 8, 3 times 5 is 15. So I claim the answer is 8/15. But why does that work? Why does that make sense? We have to go back to the fact that 2/3 times 4/5 really represents 2/3 of 4/5. So let's start by drawing 2/3 of 4/5. So if I'm going to draw 4/5, I need to draw a hole. So this box, or this square, represents one hole. So I got to chop this thing into 5 equal pieces so I can get my 4/5. So come to the middle, and then a little off to the side of the middle. Split this one in half, this one in thirds, and I should have about 5 equal pieces. So hopefully I have shaded 4/5. Right, I took one whole, I chopped it into 5 equal pieces, and I took 4 of them, so I have 4/5 of the whole. But now I want 2/3 of that whole. So I'm going to chop this thing into 3 equal pieces and take 2 of them. So if I chop this into 3 equal pieces like so, and now I take 2 of those, hopefully we can see what I have shaded in. I have shaded in 2/3 of the 4/5. And now let's look carefully at the numbers here. To cut this thing into 2/3, I had to cut it into 3 pieces going this way. And out of those 3 pieces, I then took 2 of them. For the 4/5, I had to cut something into 5 equal pieces this way. And then I took 1, 2, 3, 4 of them to get 4/5. Now I can see the total amount that I have shaded is what I want, but it was 4 pieces this way and 2 pieces this way. So I had 4/5 and 2/3 of the 4/5. So the number of pieces I have shaded in now are 2 times 4, or 8 pieces. However, the pieces are now smaller. I did have it cut into 5 pieces this way and 3 pieces this way, so I have cut it into 3 times 5, or 15 pieces, which makes each one of those rectangles a 15th. And so when we see this, I can see that I was cut into 5 pieces, then I cut it into 3 more pieces, making it a total of 15 pieces, so each piece is a 15th. I had 4 pieces, but then I cut those all in half, and so I now have 2 times 4, or 8 pieces out of the 15 pieces. And when you draw a detailed picture like this, it gives insight into why we multiply numerators to tell us the number of pieces we have, and denominators to tell us the size of each piece. So this one, both these fractions were less than a whole, right? This was less than a whole, this was less than a whole. However, the method still works even when multiplying fractions greater than a whole. So let's draw 2.5 groups of 1 1/3. So let's try this here. This is 1 1/3, and that is one group. So that means that this first box, that represents one whole. And so we have 1 1/3, you could think of 1 1/3 cups for the first batch. And then another 1 1/3 cups for the second batch. So that's one group, that's 2 groups, but I want 2.5 groups. So this last group I'm going to slice in half. And now I can see what we have here. Now, 2.5 groups of 1 1/3. We know that this is equal to 2.5 times 1 1/3. Now, if I cut these things into halves, I can see that this 2.5 is really a half, 2 halves, 3 halves, 4 halves, 5 halves. So I can see that that is equal to 5 halves. And if I chop this thing into thirds this way, I can see I've got 1/3, 2/3, 3/3, 4/3. So 2.5 times 1 1/3 is really 5/2 times 4/3. Now, what I can also see is if I were to chop all of my pieces into the same size, all the way across. Here, I had chopped my pieces into 2 pieces so that each one was a half. Here, I had chopped them into 3 pieces so that each one was a third. But when you chop it into 3 pieces this way and 2 pieces this way, each one of these boxes now represents a sixth. Right? We have 2 boxes by 3 boxes. So we now have each box is a sixth. And how many boxes do we have? Well, again, we've got 1, 2, 3, 4, 5 boxes going this way, and 1, 2, 3, 4 boxes going this way. So we have 20 total boxes, but each box is a sixth of a whole, which we can then, what is that? 6 goes into 23 times. So when 3 times 6 is 18, so 3 and 2, 6, or 3 and 1/3. And so by slowing down and paying attention to the details of the pictures, it can give insight into why multiplying numerators and denominators works. Now, it is usually much more clear, I think, in something like this where both fractions are less than a whole. However, you can still extend that concept to multiplying fractions that are greater than wholes. All right, now something else. We're talking about more on fraction multiplication. And so why can we multiply by reciprocals instead of dividing? So remember, we went over an algebraic method before. As an example, if I said 2/3 times what is equal to 8/15? Well, the corresponding division sentence says that what we're looking for is equal to 8/15 divided by 2/3. But if I started at the original problem, which was 2/3 times something equals 8/15, I could always do the same thing to both sides of the equation, which is, in this case, if I multiply both sides by 3/2. Now, 3 over 2 times 2 over 3, if we multiply as we just went over, you multiply the top, you get 6. You multiply the bottom, you get 6. 6 is equal to 1 whole, so really we have 1 whole times question mark equals 8/15 times 3/2. And 1 times anything is just that same number, so we have question mark equals 8/15 times 3/2. So question mark is 8/15 divided by 2/3, or it is 8/15 times 3/2. And so we've shown that the thing we're looking for could be represented either way. Now that's a algebraic way to go over why dividing by a fraction is equivalent to multiplying by the reciprocal, but let's look at it another conceptual way. So something we have done many times is draw pictures. So quick example, let's say 2 cups of flour make 1 batch of something. So say I draw 2 things, and I could say this represents 1 cup of flour. And then if I take both of those, that would represent 1 batch. So together, that represents 1 batch, but just one of them could represent 1 cup. And so this square by itself could be 2 things. This square could be 1/2 of a batch, or it could also represent 1 cup. We can give an amount different names because it always depends on what the whole is, right? If the cups is the whole, this is 1 whole. If the batch is the whole, this is 1/2. So let's come down here to this example and think about why we can multiply by reciprocals. So I've drawn 5 squares. I say let A equal all 5 squares and let B equal 3 of them. So if I were to take a look at one of these squares, well, this would be one of the 3 parts that would make up B, but it would be one of the 5 parts that makes up A. So this square could be 1/3 of B, or it could also be 1/5 of A. So if I want to relate A and B, I could say that A is equal to, well, if each of these is 1/3 of B, then that's 1, 2, 3, 4, 5 thirds. So A is equal to 5 thirds of B. But I could also say that this square, if I wanted to give it a different name, was a third, this could be a fifth of A, so B would equal 1, 2, 3 fifths of A. So B is equal to 3 fifths of A. So now if I turn these into equations, this says A equals 5 thirds of B, so A equals 5 thirds times B. B equals 3 fifths of A, so B equals 3 fifths times A. But whenever I have a multiplication sentence, I can also turn it into a corresponding division sentence. So this would say B equals A divided by 5 thirds. So B can equal A divided by 5 thirds, or B can equal A times 3 fifths. And it has to do with this reciprocal relationship. If one quantity is 5 thirds, so if A is 5 thirds of B, B must equal 3 fifths of A. So we've gone over a lot of the basics. And so now let's jump into just solving with algebraic methods, right? We could draw pictures, we could solve with pictures, but now we can also solve with algebraic methods and hopefully understand just about every step of it. So I have a total of 5.5 cups of flour. How many batches can I make if a batch requires 2 1/3 cups? So I should be able to say number of batches times 2 1/3 cups per batch equals 5.5 total cups. That is the equal group problem structure. I should then be able to say that question mark must equal 5 1/2 divided by 2 1/3. I should then be able to say that 5 1/2 is equal to 11 halves divided by 7 thirds. And hopefully I'm not making any mistakes. And all of these steps should make sense. And so now this last step should hopefully also make some sense, that this is equal to multiplying by the reciprocal. And now it should also hopefully make sense that when I multiply fractions, I can multiply the top and I can multiply the bottom. And then it should make sense how I can convert from an improper fraction back to a mixed number. 14 goes into 33 2 times. 2 times 14 is 28, so that leaves 5/14. And then it's a word problem. Answer the question, how many batches can I make? 2 5/14 batches. We can solve it algebraically and with pictures. All right. Next one says, if a gallon of milk weighs 8 1/3 pounds, then how much will 2.5 gallons weigh? So let's see. So this would be number of gallons, because they tell us the group size, right? A gallon weighs 8 1/3 pounds times pounds per gallon equals total pounds. You have to be able to read a word problem to turn it into a correct. So then how much will 2.5 gallons weigh? So 2.5 gallons times 8 1/3 pounds per gallon equals how many total pounds? Got to be able to take a word problem, turn it into a number sentence, and then solve that number sentence. So this is 5 halves times 25 thirds. Multiply the top, 125. Multiply the bottom, 6. 6 will go into 125 20 times, because 20 times 6 is 120. So we get 20 and 5/6. And then what were we looking for? The total pounds. All right, next one. How fast do I need to run in miles per hour to complete 7.5 mile race in 1 1/3 hours? So miles per hour is a group size. Miles in every single hour, miles per hour. So this has to be number of hours times miles per hour equals total miles. And so we have to do this in 1 1/3 hour, but what's our speed in miles per hour to complete 7.5 total miles in 1 1/3 total hours? Now again, once we get this set up, every single one of these steps hopefully will make sense. So this would equal 15 halves divided by 4 thirds, which will equal 15 halves, times 3 over 4, which will equal 45 over, that should be a 45, divided by 8. And 8 goes into 45 5 times, because 5 times 8 is 40, 5 5/8. And then the answer was, how fast do we need to run in miles per hour? 5 5/8 miles per hour. All right, slightly different activity, just to mix it up. It says, how much is shaded? So on number 1 here, I could continue to slice all of these things into equal sizes, and we could see there is 8 pieces, one of which is shaded. They're all equal pieces, so we could say 1/8. But that gets away from the purpose of this activity, which is to cover what we just went over. Now, if I were to look here, this is 1/4 of the square. And we can see this is 1/2 of that piece. So we have shaded, can I get rid of just these pieces? We have shaded 1/2 of 1/4, which is the same thing as 1/2 times 1/4, which is 1/8 when we multiply tops and bottoms. Now over here, again, you could slice this thing into equal sized pieces, and we could see that it's 1 out of 9 equal pieces. But I could hopefully also see that this is 1/3 of the overall rectangle. And I have shaded in 1/3 of that piece, which means I have shaded in 1/3 of 1/3, which should equal 1/3 times 1/3, or 1/9. Now, let's see, this is a few different pieces. This big piece here looks like it is 1/3. And then this piece here is 1/2 of that. So we have 1/2 of 1/3, and that's this piece. And then I have shaded in 1/2 of that. So I have 1/2 of 1/2 of 1/3, which 1/2 of 1/3 will be this amount. And then of that amount, I've also shaded in 1/2. So 1/2 times 1, so this is 1/3. 1/2 times 1/3 is 1/6, and 1/2 of 1/6 should equal 1/12. All right, now here's 2 different pieces. How much shaded is shaded over here? Well, this is 1/4, this is 1/4, this is 1/4, and this is 1/4. So this piece right here should be 1/3 of 1/4, and this piece right here should be 1/2 of 1/4. So if I want to know the total amount shaded, that would equal 1/3 times 1/4 plus 1/2 times 1/4, which is 1/12 plus 1/8, and we could figure out common denominators and find out the total amount from there. All right, number 5, just to mix it up a little bit, it says draw a shape and shade in the amount that could be represented by 1/6 times 1/4 plus 1/2. So this is 1/6 of 1/4 and 1/2. And so if I wanted to try to draw that shape, I could say, well, let's draw a whole shape. That's half the shape. And then this piece right here is 1/4 of the shape, but I don't want the whole piece. I want 1/6 of that 1/4. So cut that 1/4 into 6 equal pieces, and I want one of those. So here's 1/2 plus 1/6 of 1/4. Something like that. All right, that is it for more on fraction multiplication stuff.